from China, and she will tell us a bit about how AI enables microloans to thrive. And last but not least, there will be Denis Krivitski, CTO of Avoncourt Partners. He will tell us about how neural networks that can compose a poem. And just for the scheduling, it's 20 minutes each, and then we have 10 minutes Q&A. So any question we have afterwards, we can this after the whole 3 speeches and have a short, talking about it and getting pizza and beer. And we also have tickets for the lottery to data natives, as you can see here. So everything is arranged. Well, you can see not. And all these 7 stages of our data world tour, we will draw someone who will get there for free, everything paid and so on. But actually you're all the winners, because everyone who attended here can get tickets with 40% of discount. So yes. And now the stage is for Denis. Yes, and I just for the live stream, like this. Can I help? Like more cable? Yeah. Okay. Perfect. This has to be like for the live stream.
Okay. Oops. All right. Thanks for coming today. My name is Denis. I'm a developer advocate at Couchbase. For those who don't know, Couchbase is a NoSQL database. And NoSQL databases in general, they are quite handy for machine learning and big data, because most of the NoSQL databases, they are schemaless, or schema flexible, which means that you don't need to add columns. You can just store data as is. And most of the time, NoSQL databases don't support transactions, because if you need to support transactions with NoSQL databases, usually you can read and write, training your model, or when you're experienced with machine learning, because daily, basically. I have always been interested in actually putting what I learned with machine learning in practice. So my whole talk is more focused on how can I actually use machine learning in my real application. And I would like to give some overview of what's the big data ecosystem, how machine learning works in general, which trained and supervised model or framework, or which trained models can I use, and if I decide to train my own model, which frameworks should I pick. Show this big data landscape. Whoa. Yeah, in 2 years it grows a lot. But when we talk about frameworks or machine learning frameworks, the math, and you can just focus on your use case and on your data itself. But in general, I always like to talk about how machine learning works in general, because most of the time it seems something like looks like black magic. And the best example that I found so far is, hey, what is a machine learning model? And I like to compare a machine learning model with a baby. So if you want to teach your baby what's the difference between cats and dogs, probably we'll need to show some photos of cats and say, hey, those are cats. And at some point, the baby will start to understand or recognize what's the difference between dogs and cats. We call this generalization. So when your model generalizes is actually when it understood what you are trying to teach them. And then coming back to a baby, if you have a baby and say at some point if the baby generalized what you taught him, if you show a photo of a dog, he'll say and ask what is it, he'll say yeah, it's a dog. So pretty much this is how a model in machine learning works. There are many types of models. Of course, I only have 20 minutes, so I can talk a lot about them. But I would like to talk just about trained and supervised models here. I would define trained models as adopted childs. So when you adopt a child, basically most of the time they already sometimes speak. They already know how to clean themselves. They know how to feed themselves. So you don't need to learn to teach them very basic stuff. And why should I use these training models? Well, in general, because it's cheaper, right? Most of the time, we don't have time to train the model, gather all the data needed. We don't have someone specialized on this field to actually train the data. So you can basically use usually natural language processing, translations, so OCR. So yeah, you can just use service instead of implementing this yourself. So just to give an example, we have IBM Watson. They have a lot of service. Some of them are, I can show you the Alchemy language, which is right here. Yeah, so with the Alchemy language, you can basically ask it to analyze some text. So you don't need to implement, for instance, sentiment analysis, emotions, keywords, which are the entities, categories. So you can basically use those services instead of implementing it yourself. And we are talking about, actually, same with some services actually is a little bit scary for me, which is personality insights. So it can read some text that you publish on social networks and extract some features of your personality, for instance. So I can do this with my Twitter or my Facebook, for instance. But in this case, I'm just running with the demo, and then they show you some statistics about this person. So it's highly influenced by family when make product purchase. So you can get some stats. This is widely used when, for instance, you want to recognize, hey, which clients should I focus first, and which one of them is closer to make a deal, for instance. Or how can I approach this person? So you can kind of use some of those services to have an overview of what's the best type of approach on person. I'm not judging if this is fair or not to use, or if this service should be there, but yeah, you can pay IBM to use it. Another one that I would like to talk about is, of course, Google Vision API. They haven't updated their APIs for a while, but I really like the OCR service there. So I actually had a startup focused on recognizing documents, and I basically was using the Google OCR and reading the input and feeding my application. So just given it's really nice, and again really cheap. So you don't need, probably is the, I can show you something. Just show you. This is an example of a Brazilian document, and I can ask it to analyze, and they are, of course, have all the APIs. And here you can see, yeah, it's an It's an identity document. It's a Brazilian identity document. Here's the text. Some properties, yeah, which are the colors. The web is a Brazilian identity card. So you can get a lot of insights just by using those services instead of making your own, because, you know, cost is always a problem. Same with same with Microsoft. So Microsoft also has some nice service. Some of them that I like is this face comparisons. Do I look alike with this? Yeah, do I look like this guy? So let's come again. Yeah, no, I don't look like this guy at all. Do I look like Caldrogo? Let's see. Yeah, yeah, a little bit, you can say. Okay, okay, not bad. Okay. And then we come to supervised models, right? We just say, hey, it's the biological child. Because when you have a kid, your wife has a kid, you have to teach everything, like how to feed themselves. Actually, you have to feed them for a while until they learn to do it by themselves, right? And, well, this is also quite popular. So whenever we talk about machine learning, we are usually talking about supervised models. But when should I train my model? Usually when the data is private, or, yeah, the model is core of my business. If I'm building a company which detects frauds, probably I should implement my own model to identify frauds. Yeah, when the model is specific to your data, for instance, recommendation. If you have an e-commerce and you want to recommend products, probably, yeah, you should train your own recommendation mechanism, because it's according to your products, not a generic recommendation algorithm. There are a few generic recommendation algorithms, but yeah, you can do a better recommendation with supervised models. And of course, usually regressions are quite common scenario for supervised models, classifications, decision trees. Well, and how many of you here are developers? And how many of you are data scientists? And students? And okay, cool. So just to be quite, how actually I train a model in machine learning. So basically, most of the time you spend, most of the time you spend your whole your time on cleaning data, basically. So you need to compile data and try to clean and remove nulls, and then you do some feature selection. So probably if you are trying to predict house prices, for instance, probably you are going to select here, okay, I'm going to use the house size, how many rooms I have, how many bathrooms the house has, what is the house zip code. So this is basically when you come up with some features that you are going to use to predict a house price. And then you do some algorithm selection. The algorithm sometimes is not that important. Of course, it will impact the end result, but yeah, the crucial part of your model is the feature selection and data cleansing. So yeah, algorithm selection, you can try many algorithms, but most of the time the difference between them are not that big, unless you go to deep learning, for instance. Deep learning can improve a lot of results. And then you do some training, you test your model, you realize that it's terrible, you are not, you are hitting like 50%, which is basically flipping a coin. So you need to adjust your model and then train again, and you keep in this cycle until you find something which is good for you. And then you test with some external data that you haven't tested before. The reason for this is because sometimes if you keep training your model too much, you will end up with something called overfitting. And overfitting is basically, this is the best image that I found so far to define overfitting. So for those who don't know, coming back to the example of a baby, well, if I keep training my baby, maybe at some point he will, instead of generalize how a dog and a cat look like, it will start to memorize, hey, this photo is a dog and this photo is a cat. And then it will be quite good at giving the right answer for those photos, but when I come with a new one, it probably won't know, would not make will not be that good to affirm that, hey, this is a dog, this is a cat. This is kind of a very common problem, and most of the machine learning specialists here, they know that you should always keep paying attention to be sure that your model is not overfitting. Around 70 and 85% of precision. So yeah, you can, even in the very first interactions, you can get somewhere. But improving your precision is something quite difficult. And the answer for, hey, how can I improve my model or precision is not that easy. Because there are many things that you should keep in mind, like feature engineering. Maybe I should use some deep learning. I should adjust my model. I should penalize. Maybe I need to penalize some features. Where should I start then? Probably the best way to start machine learning is to study all the main algorithms. So yeah, something like regressions, Bayesian features, decision trees, and learn what they do. And at some point, once you know which are the main algorithms, you can start using some tools for it. Which ones I recommend? Well, if you are not a developer, you don't know how to code, maybe you can try, at least for a while, the machine learning studio from Azure, which I think is quite good because you basically, it just is based on workflows. So you don't need to code most of the time. Just come back here. And yeah, so you can basically start plugging boxes here, and then you can adjust some coefficients. And in general, it's quite handy. You can still integrate with coding. Probably it is one of the best options. And once your model, once you have good with your model, you can just deploy your model here and use it as a service. So yeah, I think it's quite easy for those who don't know how to code. Otherwise, I best to play and learn because it's very. You can export your model to Java code. They have a plenty of algorithms there, so it's quite easy to learn. And there is a lot of material. But if you want to implement some real machine learning models, of course, H2O is one of the most popular frameworks today. This is probably the one that people most use on Kaggle. So if you see the winners, usually they use H2O. And it's also it won a prize of the most popular Java project on GitHub. Yeah, and they launched a while ago with some nice interface. So yeah, it's quite good. If you want to also deploy something in production, probably scikit-learn is the safest choice because they also have they have a lot of material out there, and yeah, and a Python can at least give a decent performance on production, so it's also a very good choice. And there is a lot of books and tutorials and articles about scikit-learn out there. We also have MLLib. MLLib had a lot of traction 2 years ago, but right now, not that much anymore. MLLib kind of use a different approach because MLLib is focused on a high volume of data. So simple algorithms with a lot of data. So that's basically how MLLib works. And yeah, it's embedded on Spark, so usually they are used together. And yeah, my example, I usually demo this. This talk is usually 15 minutes long, so I usually demo how to predict house prices with MLLib. Well, it's still it's still quite popular today. It's one of the projects which has the most contributions on GitHub, and it's also kind of a safe choice, but not for, of course, MLLib has some very hardcore, probably not the best option. Then we have TensorFlow, which is the beloved machine learning, deep learning framework right now. Probably is, yeah, the one that you will must hear about. A lot of, since Google launched this, TensorFlow, yeah, it got quite popular, and by far is one of the communities with more engagement nowadays. They also launched the TensorFlow board, which helps a lot with visualizing and get some qualitative and quantitative analysis. Because one of the problems that we have with deep learning today is to understand what's going on, and this is a little bit of the Google effort to kind of address this issue. And of course, Keras, and this is the guy that I have spending more time on. Keras is kind of, I would define this as pretty much like SQL is for databases. So you can write a SQL query, and it will work on Oracle, on MySQL, or on Postgres, for instance. And with Keras, they kind of defined some API, some standard language, and you can use TensorFlow, CNTK, which is the Microsoft framework, and Theano under the hood to actually do what you want. So you can actually use the same code to try Theano, SNTK, and TensorFlow, which is quite handy. But of course, if you need some features, some specific features, I don't have time to talk about all the other frameworks, but I do recommend you guys to, instead of training something from scratch, to try to use some trained models. Like MotherZhu is also a quite popular website where you can download a bunch of trained models, and it's also quite easy. Yeah, this is like OpenPose, for instance. This is the one that I show you. So you can download and try yourself instead of creating everything from scratch. And of course, there are plenty of other training models out there. So for instance, this is a Facebook algorithm for image detection, and object detections, for instance. And you can basically download and try it instead of creating your own model. So yeah, this is basically what I would like to show you guys today. I still have one more slide, which is when you should not use machine learning. Again, we have a lot of problem with explainability today, and probably this will be the next challenge in machine learning, because yeah, deep learning, for instance, can do amazing stuff, but we are not even able to understand what's going on inside, and because of this, most of the time we are afraid to use this on. For instance, I was working for a company here in Munich, which builds investment bots. And hey, we are dealing with money. We can't use machine learning for that because we don't know if someday we will have some output that is totally unexpected, and we will mess up with millions of money, millions. So same with databases, for instance. Yeah, people store a lot of data in databases, of course, because that's what databases do, right? But we can use machine learning for most of the stuff because we don't know what will be the outcome of it at some point. Maybe there is some combination of parameters that will screw up and generate a very nasty result. And if you let the algorithm be your main decision, like the algorithm makes all the decisions, yeah, probably you might be screwed at some day. Not doing any important decisions. At least they are giving recommendations. So yeah, the machine learning algorithm recommends this, but most of the time it's up to a human to decide what's going to be executed or not. Yeah, of course we have algorithms and sensors and a lot of stuff. So it's not just purely deep learning. And of course, self-driving cars, it's a very complex scenario. So that's why we have been designing self-driving cars for more than 10 years to test every single possibility, because we might this can kill people. So that's one of the things that's one of the reasons why we are still a little bit afraid of putting machine learning to make really important decisions. Probably I'm already above 20 minutes, but then I would like to thank you guys. I usually talk more, but I only have 20 minutes today, so yeah, thank you very much. Oops.
At this point, you can ask questions about the speech. We have about 5 minutes because Denis was at 6. Don't be shy.
Yeah, go ahead.
That TensorFlow board, the visualization tool, would you explain what it actually visualizes? And then you also said that it addresses a challenge that the tool came up with.
Yeah, well, most of the time when you are dealing with, when you are training a model, probably you are composing a lot of algorithms in order to have a result. You're not just using a single algorithm. You usually group them together, which is called bagging. You put them all together, and then at some point you have a result, and you use this result to feed another machine learning model. So if you are at some point, this might become too complicated, and of course, if you need to change some coefficients in one algorithm, you would not like to know, okay, which other frameworks or which other models might be affected by it. So it's kind of a visual to help to understand your flow and also do some exploration in your model. So it's basically it's nothing that special at all, but it's just a tool to help data science to understand the model itself and what's going on in there. But yeah, but we still have a lot to improve in this field, because most of when we talk about neural networks, which is our third talk, sometimes it's not possible for us to even understand, given the amount of parameters what's going on inside. So yeah, but it's free basically, so you can certainly try after. Yeah. One thing is, for instance, decide. Let's say I want to decide where I should store. You can store data to and read. Let's say you're doing a logistic regression, for instance. You're going to read a lot of data from your database, or you can store on Hadoop, for instance. So or HGFS, or I don't know, HBase. So you're reading from a database, like HBase is a database, right? But the database itself doesn't use machine learning there. So because we have to predict every single behavior. So the database itself doesn't use machine learning, but of course, when you are training your model, you need to store your data somewhere, and that's when you use like a database to store your data and manipulate it. So I'm quite impressed by. I have been just came back from Rio. We have an event there for like researchers, and nobody there was using machine learning for databases, because this is quite a critical scenario, and we should know exactly what's going on when, for instance, talking about what's happening under the hood, right? If I want to shard the data, if I want to decide which index should I use, probably it's more like a logical decision than using to execute this query. So in the database world, we are not using machine learning yet. Well, one exception is, of course, recommendations of indexes. So that's probably the most common scenario. Like, okay, given your access pattern, I would like to recommend you some indexes. So then they use machine learning, but nothing like core in many of the database like Oracle, MySQL, and any other is actually using machine learning for that, because of this problem of explainability and not being sure of, if at some point I will have some problem and might screw up with the whole database. But of course, if you need to store data, probably you should use a database for it, and that's basically my personal relation with machine learning, because NoSQL is probably the first option that you should come after when you're dealing with when you're training your data and cleaning and training your model. Cool.
Great. So now, thank you, Denis, again.
Thank you.
Now it is Ziye's turn. It's your stage. This one.
Oh, sorry.
It's on this one on your back. Perfect. Ziye, you need this one. Yeah, do it like this.
Probably. Yeah. Or here. Okay.
And this one on your back. Yeah.
Yeah.
Let's do it like.
Sure. Does it go in? Hi everyone, my name is Ziye Wong. I'm from China. This is actually my second week in Munich, so it's very glad to be here and meet you guys. Just a little bit about myself. I used to be a data scientist for a couple of years, and fintech is actually developing very fast in recent decades. And because of the AI technology, it has enabled a lot of innovation through different industries, and finance is definitely the most successful out of them. So in the recent 3 years, the most successful AI-enabled products is, I think it's the online microloans in China. Starting from 2015 until the end of 2017, it has already gained around 3.5 trillion RMB in its market size. So today we're going to look into a bit and share of some of my personal experience on why it becomes so successful and how this AI application actually works. So just to give a little bit background of the development of fintech, in 2005, that was the start of the third-party payment. Some of you may know Alipay or WeChat Pay, which is very popular in China. It's essentially like PayPal, but it has much wider acceptance. So nowadays, I don't need to bring purse or card or anything. I just pay everywhere with phone, and it's accepted everywhere. So with this infrastructure set, essentially it enables a lot of things that comes up, for example, e-commerce. In 2013, there's a boosting in the commercial finance, consumer finance, and also some innovative financial products such as peer-to-peer lending and crowdfunding. And then it's the microloans that become so successfully starting to do this business. And a lot of banks also wanted to get into it. And the reason is, I believe everyone who sits here has more than one credit card. But however, there's 60% of Chinese people do not have a credit card. It's not that they don't have regular income or anything. It's just sometimes when the banks do not have a historical data of them, or that their salary is not through the bank is not confident to issue them credits. So that is the huge demand over here. And previously, there are people who want to do this business, but it's too risky because basically you're lending to people that you don't know, you don't have much of their historical data, and you don't know who actually you are lending, and it's all offline in the branches. If you put it online, you don't know who you're lending to. You don't even know it's a machine that's in front of you, or it's a real person that's lending money. So there's a whole lot of this risk. And with big data and AI technology, there are solutions. That is why, at this time point, that it becomes so successful. So let's imagine if we want to do such a business, probably the two most risky things that we would consider is, okay, if this is purely online, fraud detection is number one. We need to know that it's a person that is lending the money from you, not a machine. And also this person has intention to pay you back. And second is credit risk. It's essentially whether they have the ability to pay you back. So before we went into the very details, so just to give a very brief, introduce the process of the internet microloans. So of course it's online acquisition, and then the customers will fill in some application forms. And then in the backstage, all this data pulled into the model, which the risk would be calculated, credit would be calculated, and then the credit would be released instantly to one's bank account or other account. So through this process, this entire process actually takes only 1 to 2 minutes. So it's very fast, efficient, and user-friendly. For the online customer acquisition, during this process, there's actually a lot of data that you could collect. I believe a lot of people who sit here are data scientists and knows how important data is to a model. Because even if you use some fancy algorithms, the lift may not be as high as if you have more fluent amount of data. So it's a lot of data that you could find it over there, like the customer click, like the device fingerprints, which recognize if that's the only device and it's a true device. And through the application process, there are, of course, we want to know if it's a real person, so that's face recognition technology. What people will do is they upload an ID card with photo on it, and then the front camera would be activated, where they do some like gesture nodding or shaking, and the system would instantly compare with the photo on the ID card to make sure that's one person. Okay, so we know that's a real person that's lending, but however, we don't know if this ID card is real or it's fake. So that's what we would do an encrypted instant request to the government database to see if this is a real ID card. And then we've verified ID card as well, but we don't know if the device is a true device and holding by this person, because it's probably the same that you register your ID with the phone number. So if the loan later needs some reminder notifications, will be signed directly to the phone. So the phone must be right. So there's another device verification here. Also, through web scraping, there's a lot of other data that we could get from the device. So for instance, behavior data is what kind of apps has been downloaded and what kind of behaviors, and do they have some historical payment or credit behaviors, etc. So there's a lot of data, and all this data will be pulled into these models, which include fraud detection, credit risk, and credit line, which I will give more details in the next. So that's real-time data collection, real-time fraud detection, and scoring. In terms of the fraud detection, there's actually two parts. One is the device to recognize if it's a real person or it's not a real person, and second, to evaluate the intention, because most of the fraud would happen in these criminal groups. Like probably 80% of the criminals of the financial fraud are by the criminal groups. So since it's online, it's quite difficult to identify. So there's a lot of things like knowledge graph that we would use to build like this social network of a person. And by adjusting the weight of the nodes, we would know, for example, if we don't have much historical data of person A, but he's closely linked to B, C, D, E, and if this B, C, D, E there are a large percent of these people are on the blacklist of dishonesty or some criminal list, is definitely not a good thing to give credit to him. So there's also fraud rule engine. A lot of rules will be put inside, essentially like a trained decision tree. And of course, fraud detection model because there are a lot of different kinds of financial products. So for different products, different methodologies are used. And for the last part, I'll go a bit deeper into the fraud detection. So for the device fraud detection, there are several kinds of scenarios. For example, the device is reconfigured, which means it's a real device, but with fake device fingerprints. This would allow people to just have one machine, but create a lot of different fingerprints to make it look like a lot of different people are landing from the same place. And there are simulators, which means the device are not existing. Device here means phone. It's just the software on the computer. And that is, there's one we call device farm, which means there are real device and real device fingerprints. These are very difficult, probably most difficult to identify from all of this. What these criminal groups will actually do is that they purchase a lot of old phones or very cheap phones, and they started to like farm them as if they are used by real people. So they have a much higher success rate. But most of this, of course, problems have been more or less solved. So there are ways, for example, we do cross-validations. You get the device and you try to get the device fingerprints for multiple times and cross-validate to see if they change. And also there are some frameworks that's in these devices that can be recognized because they are the softwares or programs to change the fingerprints. And also there's something interesting to identify the simulators. Like for example, if we find a lot of devices coming from same IP address or a group of IP address, it's likely they're really coming from the same source. And also if the phone's GPS, because everyone has maps, so there's a lot of GPS data inside. So if the GPS data is not same as the operation base station, which means probably the GPS of this phone shows it's in Berlin, but the operator base station is Munich. A phone can't be in two places. So this is obviously there's something wrong. And there's also some unusual behavior mining. So for example, if it's a real person who is using a phone, you may have WhatsApp, Facebook, BBC News, and all these everyday apps on it. But for a fake phone, they may just have a few apps. They don't even have the social apps on it. So that's sort of behavior mining. And for the credit risk model, so we talked all about that. We filter out all the potential fraudulent cases. Now we come to make a decision of whether this person from online whom we don't know, should we lend to them and how much should we lend to them. So to cook this model, these are the ingredients that one can use. So traditionally for banks, and it's probably on the top of this pyramid. It's data that they get from the customer, where they would put into a model, and generally they would use linear models such as logistic regression, and they wouldn't put too much variables into it, probably max 20. And it needs to be very explainable because you're actually lending money to people. It's very risky, especially imagining this market size is 3.5 trillion RMB dollar that's been released with these models. So it's really a successful application. But apart from that, there are much more data that can be collected outside of the bank system. So there's probably purchasing history from e-commerce companies. There's operator data, which means who you're contacting to, whether these people are on the blacklist. There's this social context. There's other behavioral data. For example, are you wandering around the street at 2 a.m. in the morning? Or according to GPS, are you visiting some casino very often, or some dangerous places, etc.? With all this data blends into the model, it gives much higher lift than just the credit that's being used. So with all this data, these are the common algorithms that usually used. So instead of the linear models, because in most of the cases, this is a nonlinear world, so definitely a nonlinear model definitely have better performance. So the stacking models are mostly widely used. There are some deep learning methodology being used essentially on extracting features, because when we develop we do a lot of mining on the features, and we have like over 50,000 features. You can't dump all of that into the model, or your model doesn't give you anything. Probably overfitting is not stable. So there's definitely some pre-selection work that needs to be done in the beginning, and it helps with that. And also, Denis has mentioned before, but mostly on the supervised machine learning. However, there are more financial products coming out that probably are similar, but not essentially the same. In real case, we don't get as much labeled data as, so sometimes we would have to try some semi-supervised learning method or transfer learning. For a sample size that is not so large, transfer learning has actually quite a good result and definitely help us to use the unlabeled data. So these are the three things that we care most about in this model, which is stability, accuracy, and generalization. Stability is definitely very important because you definitely don't want to update your model every other month. So we want it to be at least be able to sustain the distribution for like 6 months. That's why through all the feature selection, every step of the modeling, we care very much about the stability. For example, we measure the population stability index to select which features been put inside. And we do a lot of tests and time series tests. And also the model accuracy and generalization. Generalization is actually very important because although we do all kinds of customer segmentation before we use different models to score them, but however, there are new customers coming that you don't essentially know, and the sample that you take is never going to be a perfect sample. There's more or less kind of bias. So the model needs to be as generalized in terms of different groups come in. It shouldn't be very inaccurate because you're lending out real money. So with all of this, we've helped some company to increase their accuracy by 100 to 200%. So it's actually, there's also a lot of banks who can getting into this area, and there's a lot of work that they could actually do and that we've helped them do. So it's been slowly shaping this industry where a lot of banks and also wanted to get into this part of the customer where they didn't want to touch in the beginning. Yeah. So that's probably what makes it so successful in less than 3 years. Okay, that is all. Thank you very much.
So who has questions for Ziye?
There are so many models that people are working on. So how do you deploy it in the sense of also take it live and then that keeps rotating? How many teams do you have? And who takes care of what part?
Okay.
So in a productive environment, how do you
Mm-hmm.
cater to it?
So the entire team has around 90 people. There's around 40 people dealing with the data. There's about 30 people dealing with the infrastructure. And there's a team of 10 data scientists working purely on extracting the features and feature mining, which takes a lot of time. And there are also a group of data scientists, around 10 to 20 people, who are responsible. One is responsible for each one of the models. And when the model is connected to join for A/B test, then it will be joined together and adjust the distributions. But generally, I would say it's more like a customer segmentation that you put in the beginning, where different customers are going through different lines. So there's not like 5 models working at the same time. Yeah, but definitely the fraud detection part is the first part before it goes to the risk solution part. Please.
Looking at the current of data types, I think something called general regulation, client would actually need to agree to all together all this
Yes.
data.
Yes.
Yeah.
Yeah, it's the same in China. Need full client consent and authorization. So in the beginning of all the process, the client would be agreed to all this data privacy. And also, a company is not allowed to store data if it's not useful, and they need to delete the data within a time period. Without consent, yeah, yeah. Nobody is entitled to collect any data without customer fully authorization.
Because I'm thinking it's not getting a bias into the data because only those who know, let's say, get a credit or they would agree to have all this data.
Yeah, but to our experience, people who need this because they can't get it directly from the bank, so generally they would agree with the terms. And to be honest, I don't check the terms when I create. Yeah. Please.
And you said that model stability is one of your major concerns and actually selling point of the whole solution. What do you do from an operational point of view to actually monitor the stability? Do you run several models in parallel to compare? Do you monitor the distribution of the data coming in and coming out all the time for the full stack of operations?
Yeah. That's a very good question. So it's very, very important as we're helping other people to lend out money, and we need to do the risk control. So we have a full set of monitoring system. It monitors starting from the distributions of all the features. So all the features that has very much importance in the model will be monitored through the distributions. And if the distribution is fluctuated, because there might be some policy change, there might be things are coming up that are unexpected, the first thing that we would do is probably to notify the customers that they should be careful when they lending out money. But definitely, the first step is to monitor the features and then the models. So every model is monitored real time. Please.
I'm curious how important are the features which are obtained through web scraping in the loan decision, and are there any cases that you give loan without any payment history or like credit history of the user?
Yeah.
What is the content, like in more detail, loan data which is obtained through web scraping?
So, well, for those, because generally most of the people would think that only if you have a credit card you will have this payment history. But however, there are a lot of histories like e-commerce Nowadays, everyone's buying online. They probably shop more online than offline. So that's all the historical records that can be scrabbled from, for example, Alipay. And of course, Alipay, you need to sign a contract with them if you want to use the data. And it's only limited to like very recent data. And also, as to your, sorry, what was your second question?
So I asked how much important is the decision, and are there any cases where you give loan without any payment history or credit history which you already
Okay.
responded? And I asked what are the contents, and if you would allow, I would just ask a minor detail as well. For example, you mentioned about Alipay. Do you request some form of login authorization from the customer to collect data from those platforms, or do you have some form of agreement with
Yes.
Alipay to do that?
Yes, there's definitely agreement with the customer, and customer would. Generally, it's not us who is visiting their account. They are basically taking out the data. Yeah. And another point is, what if we don't have all of this data? That is a knowledge graph that I was talking about. So essentially, if there's absolutely no data from this person, but we have a very large database where you can see who these persons are linked to. So that's social network. So if everyone that you're linked to is, everyone is from the same company, and you know his colleagues' credits, and that would be your model.
Last question, maybe?
If the person doesn't get the credit, are you still allowed to keep that person's data?
No, that's not allowed.
Thanks.
Okay, thank you. So now, thank you again, Ziye, for coming over from
Thank
China.
you.
And I have to mention before I introduce Denis, we have pizza after Denis' speech. So after a long day, you get something to eat finally. And Denis, it's your turn. So how to do it.
Yes.
Okay?
Machst du selber? Das hier einfach vielleicht in die Karte oder in ein bisschen leiser. Einfach, wenn es leise ausmacht. Ich mach's schon mal an für dich.
Ja, aber ich brauche es nicht. Ja? Ich denke.
Sprichst du laut? Das ist nur für einen Livestream.
Okay, got it.
Also wenn du laut sprichst, ist kein Problem, so wie Dennis.
Ich denke, ich spreche laut genug.
Ansonsten einfach klickst du.
Ich frage. Ja. Hello, everybody. My name is Denis, and I'm going to speak about a neural network that can generate poems. First question is, am I loud enough, or should I take a microphone? Great. So I will begin with a couple of words about myself. I'm coming from Israel. I'm Russian-born, grew up in Israel. I graduated in Israeli Institute of Technology, done computer science, master's degree in computer science, with a thesis in data science. And for the last 9 months, I live here in Munich. And yeah, I work for Avoncourt. Avoncourt is a small company. We are like a startup. We're trying out various ideas in the market. Most of them are connected with AI somehow, with machine learning. And okay, so most of the work we are doing is related to natural language processing. And here I present not exactly what I do in my daily job. It's a fun side project because it's more fun than the thing we are doing in the daily basis. That's why I'm presenting it here. And it's a neural network that can generate poems. First of all, I would like to ask again, how many people here are developers and know what a neural network is? Or I should explain it. Please raise your hand if you know what a neural network is, and we can go. Yeah. It's a very educated audience. Great. So I will show you how the neural network is structured, and I will show many examples of the generated poems and how they are generated and how the learning process goes. At first, let's rephrase the problem of generating a poem as a prediction problem. Why? Because we know that neural networks are great at predicting things. So we want them to predict something. So let's predict what an author like Shakespeare, Goethe, or Pushkin would say about a particular subject. Let's phrase the problem this way. Of course, in order to make such a prediction, we would need to train our model, and for the training, we will use the original poems of this author. We will train the model, and then let the model generate something. Here you see some examples. Yeah, those are real. So at first, let's break down the problem of generating the whole poem into a set of smaller problems, then solve the small problem, and then come back again to the bigger problem. So at first, let's come down to a problem of predicting one character, or just generating one character of a poem. And then we will, using a machine that can generate one character, we can generate many characters. So our machine would need to predict what would be the next character in this sentence, right? Who can guess what the next character is? Okay, so because, yeah, you laugh because it's very simple, and it's very simple for two reasons. The first reason is because this sentence appears in the training text. It appears in the text of Shakespeare, so we can just look up in the text and find out the answer. The second reason is because this letter is the last letter in the sentence. And because it's the last letter in the sentence, we have a lot of context before it to guess what comes next. Now let's see another example. Can you predict here what comes here? Now it's much harder. You don't laugh. Now it's much harder because, first of all, it's just a random sentence. It's not related to anything. Here one sentence ends, another sentence starts. We have almost no context. Everything can come there, right? Almost everything can be there and would be logical. So in this place, the machine would have a hard time of predicting what comes next. So in order to tackle this problem, we need a neural network that can read many characters, right? Remember something, remember something about what has been read, and based on this, guess the next character. So what kind of neural network is fit for this job? So maybe some of you already know the answer. It's going to be a recurrent neural network. So what is a recurrent neural network? Recurrent neural network is a network with a loop in it. It processes input one character at a time. In this way, it can take in as many characters as we want, because one character at a time, it will just loop over the characters. This loop inside functions like a memory cell. Here, this loop helps the network remember something about all the previous letters that the network saw. Now it helps to draw this network unrolled. This is the same network, the same cell, but just we unroll the iterations, okay? And the input would come in here. X0 is the first letter, X1 is the next letter, and so on until the last letter. And at every step, we have an output, okay? At every step, like HO is the letter that should come after XO, X0. H1 is the letter that comes after X1, and so on. Now let's see how this unrolled network handles our input. So the input, as I said, will go through these blue nodes, and the predictions will come through the red nodes. Here's our input, okay? So what do we expect? First of all, let's look at what we expect to get in the output. So this is the expected output. Above T, we expect to get the next letter that comes after T, which is O. Above O, we expect to get the next character, a space. Of course, we encode our poem as a sequence of characters, including spaces, commas, and new lines. And the machine needs to predict the spaces as well, and commas and new lines, okay, as well. So this is what we are expected. Of course, the actual output is not exactly as we expect. Otherwise, we will have a neural network that predicts with 100% accuracy, which of course is not the case. So this is the real output that we get. So some of the predictions were correct, some of them were not correct. Now those are the incorrect predictions, the errors, and we get quite a lot of errors here. So what we shall do to reduce the amount of errors, we should train the network. Yes, we should. And as we train it, the amount of errors goes down. So let's see how the training process goes. Now this graph shows the amount of errors, or in other words, the loss, as a function of the training process. We measure the training process here in this graph in steps. In every step, the machine learns something about the input and improves itself, and then another step, another improvement. So at the By the way, here a couple of interesting facts. You can see that we have more red letters at the beginning of the sentences and more blacks at the end of the sentences. This is, as I said, at the beginning, it's harder to predict because the machine has less of context, right? When the machine reaches the end of the sentence, it has all the beginning to reason about, okay? It has accumulated more knowledge about what's going on to make predictions. So it's like the red letters form something like a triangle here. Another interesting thing, here the network could guess the letter. It should be E, like here, but it did the case wrong. It's the uppercase instead of lowercase. Now, let's come back to the bigger problem of generating the entire poem. So we saw how we can predict one character. Now let's see how we can predict the whole poem. So every block here can predict one character, and this is how we can connect those blocks together, we chain them together to get a long poem. At the beginning, we should insert some text it's like a seed, yeah, from which we start. I love to call it the theme of the poem or the subject of the poem. Okay, my first sentence that we saw in the previous slide, the meaning of life, could be such a subject, and then we we predict what Shakespeare would write on the subject of meaning of life, something like this. And if we put a different subject here, of course we get a different poem. Okay, and here, when the subject ends, the next character is a prediction. We say it's the first character of the poem, and we relate to it as though it was perfectly predicted, and then use it as an input to the next stage. Now we assume it was perfectly predicted, we use it as an input to the next stage, and this way we can generate as many characters as we want. Now this is the same network, just drawn with just a separation line inside, okay? And this is, we can look at this network from a different perspective, from a perspective of machine translation algorithms. In machine translation, the terminology of machine translation usually says that the network has two parts. It has an encoder and a decoder. The encoder would take in a sentence in the source language and generates a meaning vector, I mean some representation of the meaning of this sentence. So in our case, we say that the data that goes on these lines is this vector. Yeah, it's a meaning vector or a subject vector. And the second part, the decoder, would take the subject vector and using it generate a sentence in the target language. This is how Google Translate works inside. And we can look at our poem generator like, so it translates the subject into a poem. So now let's see some examples of the generated text. So, and I will show you how the poem improves with the learning progress. Okay, so this is training step 1. We are just at the beginning. Yeah, this is the very beginning of the process. We are 0 minutes into the learning process. And what you can see here is just a random collection of characters. It's just random characters, nothing else, because the network is not trained at all. After 5 minutes of training, what we see is that the network learned something about the language, right? The network learned the most frequent characters. And the most frequent character here is space, is the space character. We have most of it. We also have N, R, O, E. These are just the most frequent characters in English. After 11 minutes, we see more characters appear. And now, 21 minutes after we start, suddenly we see some shape of the text. First of all, the network learned to separate words, or in other words, the network learned to put spaces in right places, right? So those sequence of characters, they look like words, right? Especially if you look from far enough. Also, the network learned to separate paragraphs, to put new lines in the right places, right? So it's like a paragraph of text, and then a new line, another new line. Every paragraph in Shakespeare's work begins with a character name, play character name, okay, like Hamlet would be here in all capital letters. So the network learned this fact and puts some sequence of capital letters at the beginning of each paragraph. Another interesting thing here. Okay, so and we also have some amount of very frequent short words appear. The word the word me, the word our, on, he start to appear, right? So the network learned the existence of those words. And the network also learned the concept of vowel and consonant. And it puts vowels and consonants in more or less right places. If you try to read those character sequences, they may sound even like words. Try to read them, or try to read this long one. Okay, and it happens because the vowels and consonants are more or less in the right places. Now, 31 minutes into the training, we have more words appearing. We have longer words start to appear. And also we have a sequence of words, even entire sequences of words. The sequences are still meaningless, but at least they all words from dictionary. 54 minutes into the training. Yes, we have longer sequences of words. 3 hours, 3.5 hours into the training, we have the first signs of grammatical structure of a sentence. You can see that it's a subject, object, verb form that start to appear here and there. "90 hours into the training, this is the point where this specific network stopped improving. From this point on, the poem does not improve anymore. Okay? This is the limitation. This network is 3 layers of LSTM of 1024 elements each. This is not a really big network, or not the most complicated network. It's a pretty simple one, and this is the result that it can produce. Here is the output of the same network trained on Goethe. The same network trained on Pushkin. This is Russian. You see that the network functions by reading individual characters. So it doesn't care about which language to speak. So we have seen a very simple neural network that generates poems. Yes, of course, the poems are not at the level of Shakespeare, they are far from. This is not the best neural network that can generate the best possible poems, far from it. It's a, let's say it's a very simple neural network that can generate something that looks like a poem, okay? And why this is interesting, why I spent time in explaining this. If some of you is looking for a good place to start making your hands dirty with developing neural networks or starting with machine learning, just recreating this exercise is a very good place to start because it's simple enough to develop by yourself and it's complicated enough to be interesting and to produce something. The code behind this talk, if you really want to do this, yes, the code of this network is available in my GitHub. You can download. The content of this talk is also available as a blog article here. The network is implemented in Python, in TensorFlow, using Estimators API. So, if yes, and if you choose to do it by yourself, please share with me your results. Maybe your generator generates better poems. Yeah. And if you have questions, I would be happy. I mean, not just now when you start developing. I would be happy to get your phone calls and answer your questions because I enjoy speaking about this. That's it. I'm from Avoncourt. Yes, we develop neural network for our customers. Usually I would say we are looking for customers, but right now we are full of, we will not be responsive. Maybe in a couple of months you can try it. It's interesting. That's it. So it's time for questions.